I have the dubious honor of introducing myself. I am new to the PCC program. Just got married a few weeks ago. Yeah, pretty exciting. And let's see, before coming here, I was working on a farm for a year as a biodynamic farm. I've been a Waldorf teacher, science and math, biology, and biodynamic farmer, and a host of other things. And my real passion is geometry, non-Euclidean geometry, also known as projective geometry. And what I want to do today is basically sort of take you on a nature hike, so to speak. We're going to traverse a geometric landscape, and I want to point out some things that I think are incredibly interesting and incredibly relevant to our current consciousness transformation birthing that we're going through. So a couple things about this hike that we're going to go on, a few basic guidelines, is that I hope if I succeed, I will point out things that will defy your ability to comprehend them, to truly think through them, because in order to really see what is there, you have to then free yourself from being anchored in a thinking that's rooted in your sense experience. And so to that end, it's going to be oftentimes challenging. So I ask that if you approach those spaces and you see things that really truly defy your ability to conceive, just make a note of it. Maybe when we get back to the parking lot, so to speak, we will be able to address some of those things. But really I want to just try to be able to show you, hopefully I can make it clear enough that where you can see the mystery, if not penetrate it. I also think that in addition to this landscape, this is also a treasure map. There's an amazing, beautiful things to be seen, and it's an escape route, because we are essentially in a prison. I'm going to tell you about that, and I'm going to tell you that I know that there's a way out and how to get to the other side. So, here we go. And we'll start simple with a line. And now we have 2 points on this line, yeah? Everybody can see that, all right? So now the question is, how far apart are those 2 points? And you can mentally answer this question for yourself. Perhaps you would say 6 feet, perhaps you would say about 8 inches, which is the way those points were on the piece of paper that I used to make this drawing. But if you said 2,000 light years, you wouldn't be wrong either, because there is no distance between these 2 points. We are simply looking at 2 points on an infinite line. They could be an inch, a nanometer, a light year. It doesn't matter. Nothing that we do in here matters according to measurement. So that's the first thing that you're going to have to sort of recognize in your own thinking and try to dissolve, which is not easy to do in 30 seconds, but just to put it out there. Okay. Now, those 2 points can relate in numerous ways, or in this way, in this fashion, in the form of lines. We had the first line that connected them. Now, each of those 2 points has, as we know, an infinite number of lines that could pass through them. And we could see that those 2 points can have 2 lines that intersect in any number of places. In fact, this is a very chaotic and truly chaotic, random place. All right, and we're just here, we're just in space. There's no confines whatsoever. But in this chaos, in this randomness, there's not a lot we can do. We could just kind of sit back and go, wow. But if we want to start to organize it a little more, we have to start to isolate and differentiate elements. So what we'll do is we'll take these 2 points, and now we'll focus on one intersection that they relate through, and use that to then build a network, a structure off of that. So in order to do so, we would have a second line, and now we need to relate these two together. In order to do that, in order to relate these two elements together, we need a third element outside of it, tying them together. And in doing so, it generates the next point for the next line, and we have now what we could call a quadrangle, and this fourth point on the line. So this right here is in essence a unit for our purposes and what we're going to look at today, this is essentially a cell. And it has very interesting properties, very much like a cell, in that it's a seed crystal at the same time. Because from this one seed crystal, we can then generate a pattern that fills the whole plane. Right? So it's generated out of that one and could fill the whole of space. No two quadrangles are identical. And we can't even begin to talk about measurement or try to like calculate any sort of area or lengths, because nothing is static. It's all dynamic, and yet it's all lawfully connected. And as we'll see in the next few slides, in order to really appreciate what's happening here, we have to move it. We have to have a thinking that is flexible enough to see how this is actually quite dynamic. So one example of that is to realize that no matter where I put this quadrangle and its generation of that fourth point there in the middle, indicated by the gold, no matter where I draw this quadrangle, I can draw any other one totally unconnected to the first one, totally randomly, anywhere in all of space. And mind you, this is really a small representation for space. I mean, this is, what, 10 by 12 or so? You know, it's beyond that. We could draw these anywhere, and they will all continue to orient and relate to this fourth point. Here's another one. So you see that the relationship of those 4 points is really tied into where that quadrangle is, or how it's structured, I should say. So you can draw it anywhere, but they will always relate to those same 4 points.
Which 4 points?
On the line. On the line. Sorry, yeah, that's a good question. Yeah.
And there was not necessarily, it seems to be, reflection from the bottom of the line to the top side of the line? Like they're not similar?
No,
okay.
Not similar. No. Yeah. So I just wanted to draw it because it can go anywhere in this plane. We're actually looking at a plane at the moment, and so now we'll move this even further. To explore other qualities of this relationship, you really have to see it in action. So here we have, again, this network built off of that seed crystal cell structure. And all of these quadrangles are related lawfully to those 4 points on the line, and yet no two are identical, and there's no measurement to be had. Now, what we're going to do now is see what happens when we move these 4 elements, these 4 points. How then does the network change in response to that? So what we're going to do is identify the one on the left. S stands for side generating for our purposes. So you see that the lines coming from S1 are all creating the sides of the quadrangle. And the D's, of course, are diagonals. And you'll see that then those are diagonal generating points. So what we're going to do now is fix the side generating points and see what happens as the D points move. So what we'll do is we'll move D1 inwards. And when we do, we see what happens. If you can all see that, the D2 has gone off the page, right? Quote unquote page. Now, here's where we transition from your physical sense-based thinking to now you have to use your imagination. I don't think any of you would doubt that that point exists if the screen was big enough, right? It's there, and you could see it in your mind's eye, in your imagination, and it's lawful and true. It's not dependent then on your senses to tell you that. So we've made that jump. Now we're outside a little bit of our sense thinking. And here's another movement. And D2 has gone even further. And it's moving away as D1 moves into the center between S1 and S2. So what happens when D1 moves into the very center between S1 and S2? Well, we'll put it there like that. And where does D2 go? Where has D2 gone? Now, this is where your thinking should struggle a little bit, because the 2,500-year tradition of training you in Euclidean thinking tells you that D2 is gone. It doesn't exist, and don't even talk about it. But we saw that something happened. It moved out there, and now it's in a weird place. And we'll come back to this, but this is our first. We're just kind of massage into this mysterious place that we think of as the infinite. But for the time being, we'll hold this as a picture that when that D1 is in the middle there, D2 has gone really, really far away. And that generates parallel lines. Now, to really appreciate the significance of this drawing, we actually have to invert the S points and D points. So let's now see that this is an S point now in the middle. It's a side generating point, and we have D2 is down there somewhere. It's generating those parallel lines. And now you see S2 is now infinitely distant. And D1 and D2 are equally spaced on either side of S1. And when we build that network, we see this. Right? And this is the first time, I should point out, now for the first time we have actually equal divisions. That this distance right here is equal to this, is equal to that. And until that happened, until that D2 was infinitely distant, that wasn't possible. So in some way, an infinitely located element is responsible for establishing equality and uniform divisions. So, and this is only two-dimensional, so we have to think, how do we get into three-dimensional space that's structured in that fashion? So we're going there. So, but before we go there, we should appreciate how significant this really is, because this enabled this to happen. This is the development of linear perspective in the Italian Renaissance in this case. I can't remember all these dates, but this is from 1481. This is the, what is it, I don't remember the name of it, something about the keys. But you'll see that in the background, this pavement, that's totally what we just drew, essentially. And it was these Renaissance painters who were trying to capture the laws of perspective. And they basically, here again, this is the flagellation. This is considered one of the prime examples of linear perspective. This is from 1460, and this is Francesca. We could probably spend 2 hours talking about all this art I'm about to show you, but I'm just going to flip through them. So here's these are actual pages from notebooks in the late early 1500s. That's a page from a man named Alberti, who worked out laws of perspective, and this is notebook from Brunelleschi, or books based on his work. And again, you see on the left there, that's essentially what we just did. Now they didn't approach it the way we did, but the geometry as it manifests is identical. And then here's another example. Now, as a way to appreciate what linear perspective did and how that reflected a drastically different consciousness, we can trace its movement through one particular focus, in this case the Last Supper. This is from 1100. This is a fresco, and we could point out numerous things, and it kind of speaks for itself in terms of where are you, and where are the figures, and where are the shadows, and all sorts of things. But one thing I want to point out to you that is quite fascinating is the halo, the gold disc. In this case, only around Jesus Christ. We'll see how that transforms. It's very interesting. So here again, we're now up to 1320, and we see that some progress has been made. It looks a little bit more like we're working with perspective lines. We see that up on the top left, there seem to be converging to a vanishing point, but it's totally different than maybe what's happening on the right side of the painting. We see that the halos are floating behind the head no matter which way the head is oriented. And figures in the back can be bigger than the ones in the front, which is very contrary to experience. Again, another example, halos, figures size of which does not correlate with your sensory experience, perspective and vanishing points that don't actually converge. But that wasn't important. Once again, I really like the guy in the middle with the halo, like right in front of his face. And so now we see it's even better now. We're getting there. We're now into the 1300s. And then, of course, we have this, which is, considered a masterful rendition of this linear perspective and its usage to convey the meaning of the image. In this case, we don't have the halos, but the next one we do. And it's incredibly fascinating what's happened to them. Oh, I don't know if you can see that. This is Masaccio. This is from 1425. This is called the tribute money, also a great example of linear perspective. But notice that the halos have actually become physical discs. And they are seen in perspective, and they just sort of float there. They are physical, whereas before they were non-physical. Well, that's interesting. So here's a prime example. You see in the tiling below and in the lines and everything that this is a drawing, an illustration of the way the world appears to the senses. And in order to make that possible, this geometry is embedded in it. Right? So there's a relationship to this in our visual experience. Now, let's go into 3 dimensions. So again, we can start with our unit, so to speak, our organized, lawful structure. Now, a new whole, if you will. And we can relate this now as a whole rather than the parts of that whole into a new quadrangle by way, again, of a third intermediate element. So here we have now 2 quadrangles, and you can see that it doesn't take much to draw that in, and we have in our floating space a projective cube. Again, no measurement is possible. Again, we could fill the whole space with a nested network of quadrangles cubes from this one seed cube. So how do we go from this to our conventional notion of space? Well, first of all, we have to appreciate that those points now are actually radiating planes. This is a way of visualizing it anyway. They're radiating planes, and those 3 pairs of planes are converging to create that cubic space. Right? And because of that, those points now are on a plane. They define a plane by virtue of the fact that they are 3 points. So how do we get this cube to look like that cube in front on the table? Well, first we can pass through this stage, which, if you want to take a moment, do you see the cube? Let me see if you... So here we have, again, the cube. And this time, this cube is drawn in linear perspective. And here are the 3 planes that are radiating in to form this cube. So now I ask you, where did the triangle go? The triangle is, in a way, the source points for those 3 planes. So where is that triangle? And in essence, where is the plane that contains that triangle? And bear in mind, it's a plane. It's totally flat, so you can't curve it, even if you wanted to. So I don't expect you to really have the answer to that right now, but it's a question that is worth considering. Because furthermore, where does the triangle go when this happens? Right? So this is a very unique situation, and it's one of any number of drawings that we just did, and they're all lawfully related. But this is, in many ways, a special case. So again, here we were. How do we get from this to the perfectly regular cube that you can see right there? So a way to visualize this, a way to take your thinking out to that infinitely distant plane of space that we need to get to, we can visualize here a circle. And a circle can be regarded as made up of the points equidistant from a common center. This is a common definition you'll find in geometry. Imagine this is actually a whole string of pearls, really, and that there's an infinite number of them. But one thing we know about every point on a circle is that there is one tangent line that passes through each point, like so. So thus, we can draw a circle not only as the points equidistant from a common center, we could draw a circle as all the lines, the tangent lines. And now, these lines are not relative to a common center. They're actually enveloping or radiating in from a distant periphery, from the opposite of the center point. And you have to imagine too that were I to draw in every one of these lines, the whole screen would be white outside that circle, because the whole of this plane would be filled with those lines. There's actually, if we can speak of substantiation or substance, the outside composed of this line-built circle is substantial, and the inside is vacuous or hollow, as opposed to the point-built circle. Now, what happens when that point moves away from the membrane, so to speak, the body of the circle? Where does that tangent line go? Well, using the same quadrangle construction that we used earlier and the lawful relationship that's embedded in it, we can find that the tangent line has moved away, like so. So in that sense, we can visualize that whole circle of points having contracted. What then happens to that circle of lines? It is now expanded out. So now we're going to take the next step. What happens when that circle gets smaller? Where does that circle of tangent lines go? It's no longer something that I can represent on this screen, but it's, here. And you can only see it in your imagination. You have to let go of what you can see right now. But it's there. It's mathematically real as abstract math could be, I guess. It's another topic. So here we go, the final stage. What happens now when those points all converge into the center point? What has happened to that circle of lines? Where has it gone? And bear in mind that when you think about that circle of lines and I look in that direction, it's going to face me perpendicular. And it's going to face me in this direction perpendicular. And this way, like a mime. And yet, those points are all on one flat plane. And, well, we'll get to that. So let's go back. I jumped the gun a little bit. Let's go back. Let's reverse this process. Let's imagine instead an exploding point radiating out from this center location. What then happens to that circle of lines as a response to this movement? As those points come back in, that circle of lines breathes in with it. So there's a reciprocal and breathing and rhythmic relationship between these two circles around the mediating element of the circle that we held fixed. Which, of course, the circle could be 2 inches or 2 light years. The circle size doesn't matter. Okay, so let's go back to this for a second. Where is that triangle? That triangle is on that infinitely distant plane that was composed of those infinitely distant lines that you just maybe attempted to see. And it's a really weird place to think about. But this right here is embedded in our conventional scientific understanding of space. This is a Cartesian coordinate axis representation. And this is what makes measurement possible. So you see that by thrusting those generating elements of the cube to the infinitely distant beyond, that is what made this possible, this homogenization of space into equally divisible, uniform, static, frozen units that then make it possible to use a ruler at all, or to build a structure. Now, because of that, because of this organization of space, let's go back a second. The infinitely distant elements are cast out as far beyond your thinking as literally possible. And as a result, we shrink into this point right here. And this is in a way that a Cartesian ego culmination into utter contraction into this one singular point. And this point then is embedded in a space that is so homogeneous that it's in essence disembodied. So the infinite element that actually is an incredible aspect and organizing element of this space is thrown so far out beyond our thinking, and we don't ever go there. We're encouraged not to go there, but it's exactly where we need to go to then recognize how much this space is actually a participatory space. So it's by breathing with the infinitely distant elements in our thinking, and this is a wonderful way to do it, that we can then recognize that it's not just a space, a pattern that's independent of a matrix. Right? The matrix is present. And here's an example of that, like we saw before. This is, in a way, imagine this as utter chaos. Imagine this space filled with all of the lines through those points. And imagine this space filled with all of the points in all of the plane. Right? This space here has no inherent structure that's measurable. It's, as Brian says, an all-nourishing abyss. It contains all lines, all points, and all planes simultaneously, and yet not at all in manifest. But capable of being organized, yet itself having no inherent organization, at least in the Cartesian sense. As we saw, I hope to have demonstrated, there were organizational principles that become manifest when your thinking participates in the becoming of these forms. But when you just study Euclidean geometry and form that's come to rest and the properties inherent in it, you will never get outside of those fundamental presuppositions about the nature of space. And so this is a way to do that. And so here we see this unit again, a self-organized and essentially holographic or holonic, however you want to say it, element that can appear in any number of places and display the same lawfulness relative to that line. So this line, those 4 points on that line contain a relationship that is expressed in any one of these quadrangles and yet is not contained or strictly reduced to any one of those. So in a sense it's very similar to the archetypal plant or the phenomena in general. So where are we going to go next? So here's the question, which of these is true? Which of these depictions of a cube really captures the nature of space and structure? On the left there, upper right, we have the 3 points and their relationship to the cube. On the upper right, we have the world of linear perspective, the geometric experience of this visual field. And you see that even there, we've had to send some of those elements to the infinitely distant plane of space. And finally, in this cube here, in this totally homogenized space, which is only then capable of being measured and calculated, only then, when we can do that, it's built upon the idea that those points have been cast out as infinitely far as possible, which at the same time collapses us. So how do we then breathe that? How do we undo that latticework prison that actually maintains the mystery, the infinite spirit beyond, and says essentially and reinforces in every right angle and every structure that surrounds us that the infinite is unapproachable and is nowhere to be found or experienced. It's inherent in this right angle, or even the convergence of the right angles of 3 axes. Right? So how do we get outside of that? Well, I mean, I guess that's the big question. And I think projective geometry, this way of approaching archetypal space, is a way to learn to recognize what is true and lawful outside of one's own perspective. You can then actually see things from different angles, or in this case, as I'm going to try to show you right now, you can actually go to the infinite in your thinking and turn around and see how space is structured. So here's a circle, or a sphere, if your imagination is up for it, if you're feeling particularly hardy. Picture a sphere that now has a center that is moving upwards and is lifting off. And as we do so, this sphere is slowly opening up and expanding. So as that happens, the curvature of the sphere gets greater and greater. So great that it becomes the flat line. That a line is a way of seeing an infinitely expanded sphere or circle. And unlike the previous infinite thought adventure where we stood in the center and watched the lines recede to the infinite periphery of space, here we're on the edge, and conceptually, in our mind's eye, if you're really here, you're standing on the infinite plane, looking inwards. And when you do this, you start to recognize that on the other side of phenomena, on the other side of form, is that participatory element that radiates in from what we typically think of as the infinite. Is that time? I'm almost, 2 seconds. Okay, so we can actually go to the infinite and turn around and develop this consciousness of the other that then stands actually in this more enveloping gesture rather than the point-centered, ego-based consciousness that was typified by that expansion. Here we have now a radiating and enveloping form. And so these are just, I think, seeds for our new thinking. And so I want to leave you with a verse by Rudolf Steiner, who really was the inspiration for the first pioneers to start to put together the fruits of modern synthetic geometry and what Steiner described as the etheric world. Some other date we could totally talk about how this is the geometry of organic form, but we don't have time today. So I'll leave you with this verse. The stars once spoke to humans. It is world destiny that they are silent now. To be aware of the silence can become pain for earth humans. But in the deepening silence, there grows and ripens what humans speak to the stars. To be aware of the speaking can become strength for spirit humans. Thank you. Do we have any time for questions? No. Quick questions, maybe? No.
Do we have time?
It's 11:22.
Okay, we're already 7 minutes over.
All right.
Yeah.
Okay, well, questions can be had, yeah.
Were you speaking literally or not when you were describing the movement from the early pre-perspectival images to the perspectival as progress to how we really see things? Or
No.
Okay, good.
No. No, as an indicator of the consciousness that was at work in that, but not, no.
Okay, great. To be continued.
Yeah. All right.